Hi everyone, I welcome you all to the part 2 of the number system chapter, and today we are going to discuss about the real numbers and their decimal expansions. So just tell me, I hope you all know what are decimal expansions, right? What are decimals? Basically, if you know decimal, then we would continue with that. So the first question says that you need to express 10 by 3 in terms of decimal expansion. So what you want to do is just simply divide 10 by 3. So it will be go by 3 3s are 9 and the remainder would be 1. Okay, so again a 0 would be created pointing. So this would be 0, again 3, 9 in the same manner one would be arriving at every step. So we made a conclusion that its decimal expansion is 3.33 and 1 is coming remainder for long. Like we won't get remainder 0. Okay. Similarly, you can solve the other two in same way and you're going to discover that there are some divisors of rational numbers such that these numbers don't lead to remainder 0. So, same is written here. The remainder either comes 0 after a certain stage or start repeating themselves. So, the first type is the number of entries in the repeating string or remainder is less than the divisor. Correct? And the third is if the remainder repeat, then we get a repeating block of digit on the question. From this can be checked from the first question which we did. We were getting 3 multiple times, right? Every time we were getting the remainder 1. So the same remainder repeats and it leading to the same block of questions. Okay. So from that we draw two conclusions. The two cases are remainder becomes 0 and remainder does not become 0. So in case when remainder becomes 0, we call it terminating. Like it's showing the end. But in case when the remainder is not becoming 0 and we get a repeating block of digits in the question, then we state that it's a non-terminating or non-wrapping expansions. Okay, so these are the two types of expansion which you might want to learn. Now the question says that you need to express this as a rational number. Now you might be worried like how to express such a big number, but let me be short, you a hint, a short form. Okay, so just write the number as it is. Whenever there is a decimal question and you need to ask, so you are asked to represent it as a rational number, you just simply write the number without the decimal point and count the number of digits after decimal. Here it is 1, 2, 3, 4, 5, 6. Put a 1 and 6 zeros. So yeah, it can be expressed as P by Q form where Q is not equal to 0. Hence proved it's a rational number because it satisfies the condition of a rational number. So it's your answer. Okay. Similar way you can solve other questions whenever it's asked to express rational numbers. Okay. So your given show that 0.3 can be expressed in P by Q form. Obviously it can be expressed. We have solved this question. It's 10 by 3. Right? So it can be expressed in the form of P by Q where Q is not equal to 0. So this is shown by this, hence we consider 0.33 which is a non-terminating but it's a rational number. Okay, correct? Okay, moving towards now 1.2727 can be expressed in the form of P by Q where P and Q are integers. We need to show for 1.27. Try it for yourself for a minute. Just pause me and try it out. If you could arrive at a solution, it means you are listening to me carefully. Okay, go ahead. Okay, I hope you have not found the solution. If you have found, well and good, I'll show you a simple trick. If you haven't, don't worry. Like, I'm not asking you to think of a number which gives 1.27 terminating. In previous question, 0.33 was easy because we have just seen an example. Okay, but here's a simple method to solve this type of question. Now, just come with me. Count the number of digits which are terminating. It's 2, right? Okay. Now, let x be the number. Okay. Now, since the digit of terminating or repeating digits are 2, so we'll multiply it by 100. Okay. So, 100 into x is equals to 100 into 1.27 bar. 27 bar shows 27 are repeating. Okay. In previous question, we could have bar over 3. Okay. Yeah. So, it will be 100x equals to 127.27. Okay. So now, this is our equation number 1 and this is equation number 2. We could subtract 1 from 2. What we would get? 100x minus x, 99x. 127 bar minus 1.27 bar is 126. So x will be 126 by 99. This is your final answer. Okay. Now come with me. We'll solve this question again using the method. Okay. Now count the number of digits repeating. So n is equal to 1. To let x equals to 0.3 bar. Since it's 1, we'll multiply it by 10. So 10x would be equal to 3.3 bar. Now subtracting both the equation, we would get 9x equals to 3. And simply we would get 1 by 3. Okay. So here is the solution to your simple question. Okay. In this way. I hope now you're clear about how we are doing such questions and how we are solving. Okay. So see, 1 by 3 we earlier got it by just thinking of a number which could be divided and would give 0.333, and we could use the simple method too. Okay. So in this way I have drawn two questions in front of you. I hope which are clear. Okay. Okay, next again the same question. Now you would do this time for me. Okay, n is 3 here, so we'll multiply by 1000. Okay, so first statement would be let x equal to 0.235 bar. Okay, so 1 2 3 1000x equal to 235.235 bar. 1 minus 2 equation would give 999x equal to 235 and x equal to 235 divided by 999. Is this in the form of p by q where q is not equal to 0? Surely yes. So this is the desired result. Okay. Yeah. Now, decimal expansions of irrational numbers. In case of rational number, there were two suggestions or two possibilities. Either it's terminating or it's non-terminating but recurring. Okay, repeating. Moreover, a number whose decimal expansion is terminating or non-terminating recurring is rational numbers. We can say that. Now, similarly in the case of non-rational numbers, we arrive at a conclusion that this decimal expansions are non-terminating and non-recurring. Moreover, a number whose decimal expansion is non-terminating and non-recurring, we consider that number as irrational numbers. Suppose pi. See that there is no pattern followed. The numbers are not repeating, but they are not terminating too. So non-terminating, they are not stopping, but non-recurring, they are not repeating. Okay. So this way is to identify types of rational numbers. I hope you're clear about the types for both, how to identify whether it's a rational or irrational number. You can see the decimal expansion. So these questions are frequently asked in MCQs too. Okay, so find a rational number between 1 by 7 and 2 by 7. So in order to solve this type of question, firstly we would have to find the solution for this. Okay, so what's 1 by 7 and 2 by 7? When we would divide 1 by 7, you simply need to use the division method and you would arrive at a conclusion that it's equal to this number that I'm writing and it's terminating. Okay, and for the 2 by 7 also you would get a number 285714 and it would be terminating. Correct? So now we have to find a number in between which is an irrational number. So you know that irrational numbers are non-terminating. Okay, and at the same time they are non-recurring or repeating. You could write either way. Okay, so think of a number in between. So I could write 1.150, 15000, and so on. Okay, so is this a rational number? Yeah, it's a rational number. Or could I write 1.1601600 or any number in between the above two? So there can be a plenty of numbers which you could write. Okay, now I hope the things I have covered till now are clear to you. Moving ahead, we would be using representing real numbers on the number line. Okay, so how you represent the real numbers? Locating decimal on a number line. Now, suppose you are required to locate 2.665 on the number line. How would you do that? Firstly, simply create a number line. And you know that 2.665 is greater than 2 and less than 3. So we would zoom in on the area of 2 and 3. Okay, now you would see 2 and 3 area can be divided with 2.1, 2.2 and the smaller fractions. Okay, Now zoom into the area 2.6, 2.7, because this number lies between 2.6 to 2.7. Again, we can further divide into 10 parts and we would come to the 2.665 number. Okay, so in this way you can represent 2.665. Okay, so this process of visualization or representation of number on the number line through magnifying a glass is called as process of successive magnification. Why it is successive? Because we need to magnify at every instance, okay, to come to the conclusive numbers. So let us see if it's possible to visualize the position or representation of a real line with a non-terminating decimal expansion, okay, non-terminating and recurring decimal expansion. Okay, so visualize the representation of 5.37. We know that 5.37 is repeating, 37 is repeating, right? And up to 5 decimal places, that is up to 37777. Okay, so firstly what we would do, we would target to 5 to 6 area, and simply we know that 5.37 is greater than 5.3 but less than 5.4. So we will again zoom in, and after again zooming in, we can find it. This 5.3 to 5.4 is again divided into 10 parts. Now 5.37. So 37 would line here, but 377 it's there. So 3.75, 5.37 to 5.38 would be under consideration, and we again divide it into smaller parts, and finally we keep on dividing and find the 5.37. Okay, so this is successive magnification. I hope you are clear with the lectures today and all the topics that we have covered.